This chapter is all about parallel lines and transversals. First, we need to go over some vocabulary in order to understand what we're going to be doing the rest of the chapter. A few things are self-explanatory, others need a little bit more explaining. The first one is a parallel line. The definition is, if two lines are parallel, then they do not intersect. And in order to show that they are parallel, we draw these little arrows. Sometimes they're closed, sometimes you have two on each line, depending on how many sets of parallel lines you have. Okay, another way of writing line A is parallel to line B is we show that we have two little lines straight up and down next to each other, saying that they are parallel. Skew lines is if two lines are skew, then they are not on the same plane, and they do not intersect. So they cannot share any part of a plane, and the lines can never ever intersect. So here we have line A is skewed to line B. Parallel planes are if two planes are parallel, then they do not intersect. Think about your floor and your ceiling. Those two floors and the ceiling will never ever intersect. They will always be parallel. So here's an example. It says, think of each segment in the diagram as part of a line. So this is just one portion of the shape that we are seeing. It does extend forever. Which of the lines appear to fit the description? So we're looking for a line that's parallel to AB. Here's AB. That has to contain the point D. So think about what parallel lines look like, and if you notice here, DC is parallel to AB. So DC would be our answer. Now, not every time it's going to tell you that it must contain D. Okay, so if it didn't say that, you could have said HG is parallel, EF is parallel. Those are other examples, not including G. Which line is perpendicular to AB and contains point D? Now, perpendicular means it forms a right angle. So this line here goes through point D and is perpendicular to AB. So DA would be the answer. The next one is which line is skew. So remember, they are non-coplanar, which means they are not on the same plane, and they will never intersect. So AB and let's say DG, both of those are on two different planes, and those lines will never ever intersect. So DG is another example of skew. The last one we have is name the plane or planes that contains D and is parallel to plane ABE. ABE is this plane here. What is parallel to that? This line here, or this plane here, I'm sorry, will never intersect that one. So plane DCG is parallel to plane ABE. There are two postulates you need to know. One is parallel and one is perpendicular. Postulate, remember, is your rule. So it says through a point not on a given line. So notice how here we have a point not on this line. There exists one and only one line through the point parallel to it. So that means that there's only one line I can draw through this point that would make this new line, we'll call it N, parallel to M. Same thing with perpendicular. It says if there is a line and a point not on the line, then there is exactly one line perpendicular to it. So that means that you can only draw one line perpendicular to that given line through the point. That would make it perpendicular, because if you were to draw this 1 degree off, then you're going to have not a 90-degree angle. Now the question is, what is a transversal? A transversal is a line that intersects two or more coplanar lines at different points. So in this picture we have 3 lines total. We have line R, line U, and line S. The transversal is always the one that passes through more than one line. So it intersects R and it intersects U, so line S is the transversal. There are different types of angle pairs that are formed when you have a transversal. The first one is corresponding angles. But first you have to always identify what is your transversal. So you look to see which line goes through 2 or more lines, intersects them. Notice how we have all 4 of these angles formed when that line M and the transversal intersect. We have 4 more angles that are formed. So what this means is that each of these has a specific location. Corresponding angles means that your specific location is matched. So you have angle 1, which is in the top left corner, and angle 5, which is in the top left corner of that second set of angles. So 1 and 5 are corresponding angles. 2 and 6 are also, because they share the top right corner. 3 and 7, and 4 and 8. Corresponding shares the same position. The next few are pretty much self-explanatory. Alternate interior angles means that you're only talking about, if this is our transversal, you're only talking about the angles that are inside of those 2 lines that are cut by the transversal. So 1, 2, 7, and 8 are kind of gone. So alternate interior angles means that if you have this 3, you have to go over the transversal to get its alternate. So 3 and 6 are alternate interior angles, along with 4 and 5. Alternate exterior angles are the angles on the outside of the 2 lines that are cut by the transversal. And again, since it's alternate, you have to cross over the transversal, so 1 and 8 would be your alternate exterior angle pairs, and 2 and 7. Same side interior angles means that even though you have this transversal, we're still talking about those numbers on the inside, the interior, but now you don't have to cross over the transversal because it says same side, so 3 and 5. 4 and 6. If I said same side exterior angles, it means you're talking about the angles on the outside. So 1 and 7 are same side exterior, 2 and 8 are same side exterior. Here are some examples. So the first thing you should always do is find your transversal. The transversal, again, is the line that intersects 2 or more lines. So notice line T intersects N and M. So corresponding angles, remember you have to choose the same location. So in this case, 8 and 6 are corresponding angles. 7 and 5 are corresponding angles. 1 and 3 are corresponding angles, and 2 and 4 are corresponding angles. Alternate interior angles for this example, remember you look at the inside of the 2 lines that are being cut by the transversal. Since it's alternate, you go across the transversal, so 7 and 3, and 2 and 6. Alternate exterior angles means that you're now looking at the outside numbers, and you are crossing over the transversal as well. So here you would have 8 and 4 and 1 and 5. Same side interior angles are back on the inside of those 2 lines. Same side interior means that they are on the same side of that transversal. So you have angles 2 and 3 and 7 and 6. Here's one more example. I want you to identify the transversal, try all four, please read them carefully, and then hit play again to check your work. Here are your answers. Check your work. If you have any questions, make sure you either email me or come in and see me in the morning. Have a great day.